Okay, this is review for Unit 3, Triangle Congruence, Ratios, and Similarity. Okay, on number 1 it says, given each set of congruent triangles, complete each of the following. Okay, so we have that triangle RSP is congruent to triangle FOE. Well, we don't have a picture, so we're going to draw one. So I have RSP is congruent to triangle FOE. Remember, when you're naming your triangles, make sure you go in the same order. So I started at R, went to S, and came back down to P. Same thing, start bottom left. So F, up to O, back down to E. Okay, on the first one, so it's saying angle S, which is right here, angle S is congruent to angle O. Angle P is congruent to angle E. Okay, they're in the same position, and angle R is congruent to angle F. Okay, for your segments, the first one is FO, so start bottom left, go up. Same thing with your other triangle. Start bottom left and go up. So FO is congruent to RS. EO is congruent to PS. And EF is congruent to PR. Okay, and on the last one, it says triangle SRP. So start at the top at S, come down to the left at R, and go over it to P is congruent to the triangle. Okay, you have to do that same format. So you're going to start up at O, come down to the left at F, and go across to E. So triangle SRP is congruent to triangle OFE. Okay, on problem 2, it's asking you to determine whether each statement is true or false. If you don't have a picture, I would probably draw one. Alright, here we go. So your first part of information that's given, it tells you that ABC is congruent to XYZ. So let's get those two triangles. So I have ABC is congruent to triangle XY and Z. Okay, with that information, it says, does BCA, so start at the top at B, come down to the right at C, and go to the left at A, is that the same as starting at Y, coming down to Z, and going over to X? And yes, it is. So that one is true. Okay, I'm going to use for part B, I'm going to use the same picture, so I don't have to rewrite it, because if you look right here, so ABC is congruent to XYZ, that's the same thing right here. Okay, so now I'm trying to see if ABC is congruent to XZY. So ABC, is that congruent to XZY? No, it's not. I did not go in the same order, so it is false. Okay, on the last one, it's the same picture. Okay, so this is the same thing, so I'm just going to use the picture that I have right here to determine if BCA is congruent to ZYX. So that just means it go in the same order. So start at B, come down to C, and over to the left at A. Is that the same as starting at Z, going up to Y and down to X? No, it is not. So that one is also false. Okay, remember, order does matter. Okay, and number 3, it says determine whether the following triangles are congruent by, you have your options SSS, SAS, which is side angle side, ASA, angle side angle, AAS, which is angle angle side, or HL. HL means hypotenuse leg. Okay, or it's not congruent. Remember, you do not have AAA, and you do not have anything that makes a bad word. So ASS, or if you go backwards, SSA. That's not going to work. Okay, on the first one, both of your triangles, since they're congruent, they're going to have the same markings on them. So just look at one triangle and just read it going in order. So I'm going to start here. Okay, a tick mark is for a side. So this is a side. Okay, I'm going to go around. The next thing I see right here, that curve mark, is for an angle. And then the next thing I see is a side. Okay, it was in the correct order. Nothing was skipped over. You have this side, the next thing you see is this angle, and then the very next thing you have is another side. So this is congruent by SAS. Okay, I'm going down to C. So it doesn't matter where you start. You can start on the left and come to the right, or you can start at the right and come to the left, okay? It's going clockwise and counterclockwise. It doesn't matter which way you start. So if I'm going to start at the left, I have a side, and then I have an angle and an angle. So that is side, angle, angle. But if you look at our options, that matches AAS. So it's going to be congruent by angle, angle, side. Okay, we're going to go down to E. You can prove these congruent two different ways on E. Okay, so the first thing you can do is what I see is I see this right angle mark. So since I see that right angle, the first thing I'm looking for is the side opposite from the right angles. Are they congruent? Yes, they are. How do I know that? Because I have this tick mark right here. So since they have the same tick mark, that means they're congruent. Okay, also remember the side across from a right angle is called the hypotenuse. So this is your hypotenuse. So I do know that my hypotenuse is congruent. And then if you look right here, you have another side congruent or another leg since it's a right triangle. So you can prove this congruent by hypotenuse leg, or if you notice what we've talked about in class, this triangle, both of these triangles, they share that common side, so that's a reflexive property, okay? It's congruent to itself. So it's HL, or you could also prove this congruent by side, side, side. Okay, so this one has two options. Just make sure on the test it's going to be multiple choice. You choose the best option. Let's go back up to B. Okay, you have an angle, okay, a side, and an angle. So that's congruent by ASA. On D, you have all of your sides are congruent. Okay, so since all of your sides are congruent, it's congruent by SSS. Tick marks are for sides, curve marks are for angles. Okay, and this last one, you have an angle right here, okay, and then you have the side. Okay, I need something else. Remember, most of them you need 3 congruencies. You have to remember that these are vertical angles. Okay, vertical angles are equal. So now since I have vertical angles, I have an angle, a side, and another angle. So it's congruent by angle, side, angle. Okay, for number 4, it says write a 2-column proof for each of the following. Make sure you know what is given first. Okay, so on this first one, it says given YT bisects DH and DH bisects YT. You're trying to prove that triangle YOD is congruent to triangle TOH. So the first statement that I have, I'd already typed up. It's YT bisects DH. Y'all cannot miss these first ones. They are so easy. Okay, all you have to do is read. If you will read, you will know what your reason is. Okay, so your first reason is given. Okay, after you're given a piece of information, you need to label it. Okay, so YT bisects DH. So it's telling you that YT is going to bisect or cut in half DH. If it's going to cut it in half, that means it's going to give it 2 equal parts. So that means DH is going to be cut in half into 2 equal parts. Okay, so whatever you label is your next statement. So I just labeled that DO is congruent to OH. Okay, so I'm going to put that here. I'm going to make my little congruent symbol in between. I don't know if I left enough room. Okay, now, how do you know that those are congruent? Okay, what did you use to get there? You just used the definition, not dry, definition of a segment bisector. Okay, that's how you know. The next statement, okay, if you look right here, it's telling you that DH bisects YT. Okay, that has to be your next statement. If that's your next statement, if you know DH is going to bisect YT, that means YT is getting cut in half. That means you're going to have 2 equal parts. So that means YO is going to be the same as O to T. Okay, now first, how do I know that DH is bisecting YT? Hello, it's given, so that's your reasoning. So we're going to type that in, so we know that's given. Okay, then remember, once you label it, I kind of jumped ahead on that one, my bad. Once you label it, which I did right here, okay, I said that those two segments are equal, then you need to go ahead and write that. So that means now I know that YO is congruent to OT. Okay, and I'm going to put my little congruent symbol in there. Okay, how do I know that's true? How did you get that? Well, it told you that it was a bisector, so that's just the definition of a segment bisector again. Oh my gosh. Okay, now I have two things that are there. Remember, when you're proving triangles are congruent, you need most likely 3 unless it's hypotenuse leg. Okay, I have two sides. I know that vertical angles are congruent. If you look right here, y'all, you have those two angles are congruent. Okay, now since the letter O is shared between both triangles, you're going to have to name your angle with 3 letters. Okay, never start at the middle. O is where our angle is, so we want to start on an endpoint. Remember, you're going to see which two segments make angle O. So on the first one, I have the YO and the OD. So if I'm forming that angle, I'm going to start with angle Y up to O and down to D. So I have angle YOD is congruent to angle, go the other way. So what two angles or what two segments are formed by the other angle? I have OH and OT. So that angle is going to be HOT, or hot. So angle HOT. I know those are congruent. How do you know those are congruent? Because they are vertical angles. Okay, and whatever you are trying to prove, okay, I'm trying to prove those two triangles are congruent. Whatever it says to prove, that has to be your last statement. Okay, so triangle YOD, that's a no, is congruent to triangle TOH. How do you know that's true? You have a side, another angle, and a side. So it's congruent by side, angle, side, and that's your reasoning. Okay, on number 5 it says given IG bisects angle FIH, and you're given that F is congruent to H. You're trying to prove that triangle FGI is congruent to HGI. Okay, the first one, it says the statement is IG bisects angle FIG. How do you know that? Do not miss that. It is given. Okay, now go make sure that that's labeled. So it's telling you that IG is going to bisect angle FIH. Okay, so that means if it's going to bisect, that means it's going to cut it in half. That means you're going to get 2 equal angles out of that. Okay, what 2 equal angles are you getting? You're getting angle 1 is congruent and angle 2 is congruent. So once you label it, write it. So you know angle 1 is congruent to angle 2. How do you know that? Because you use definition of an angle bisector. You use the angle bisector to cut it in half, and that's your reasoning, so thank goodness. Okay, on 3, if you look at the reasoning, it's given. So what other piece of information was given to us that we have not written yet? We know that angle F is congruent to angle H. How do you know that? Because it's given. Okay, make sure you go and label it. So I know that F is congruent to angle H. Okay, and the second to last statement, it says IG is congruent to IG. Okay, so all that's saying is that something is congruent to itself. So IG is congruent to IG. If something's congruent to itself, y'all, it's always reflexive. That's a reflexive property. Okay, that never goes away. So that's telling you that that side is equal. So now it's saying, how can you prove those triangles are congruent? So you have side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. If you read it in order, go clockwise or counterclockwise. Okay, I'm looking at this triangle right here. I have an angle. The next thing I have is another angle, and I have a side. So it's congruent by angle, angle, side. Okay, and number 6, it says given JK bisects angle FGH and angle FKH. You're trying to prove that triangle FGK is congruent to HGK. Okay, the first thing it says, we have a statement. We got to figure out what our statement is, but if you look at the reasoning, it says given. Okay, so we're going to write GK bisects angles FGH. My handwriting is awesome. And angles FKH. Once you write something, go label it. Bisects, JK, or GK, I don't know my letters. Bisects means it's going to cut it in half. Okay, so the first thing it says, it's going to cut angle FGH. FGH. So you have this whole angle, it's going to cut it in half. Cut it in half means you're going to get 2 equal angles. Okay, so I know angle 3 is congruent to angle 4. Okay, and it also says that we're bisecting FKH. You can bisect more than one angle, y'all, that's fine. Okay, so if this angle is also bisected, that means that has 2 equal parts. So we have angle 1 is congruent to angle 2, and I'm going to name it with 2 awesome curve marks. Okay, now if you look at your picture or your statement, it says 1 is congruent to 2. How do you know that? What did you use to say that 1 is congruent to 2? Well, remember we said that JK bisected that angle. So since it bisected that angle, that's definition of an angle bisector. On 3, your statement is blank, but look at your reasoning. Again, it's definition of angle bisector. So we already used 1 and 2, but remember, we also cut 3 and 4. We made those equal angles. So, and we use that by our angle bisector. So our next statement has to be that angle 3 is congruent to angle 4. Step 4, it says that KG is congruent to KG. Anything that is congruent to itself is the reflexive property. So make sure you go label that. So it's a segment, so I'm going to use a tick mark. Okay, now how it's saying, hey, you better be able to prove these triangles are congruent. How can you prove them congruent? Doesn't matter what order you go in. I'm going to start at angle 1, and I'm just looking at the top triangle, and I'm going to go in order with what is labeled. So I have an angle, the next thing I have is a side, and I have another angle. So it's congruent by angle, side, angle. Okay, number 7, it says find the value of x. Okay, remember a triangle has 180 degrees, so this plus this plus this has to equal 180. So if you add 75 plus 48, you're going to get 123. So you have 123 plus x equals 180. Okay, when you subtract 123 on both sides, okay, you're going to get x equals 57. Okay, on 8. This symbol right here, that little box tells you that that's 90 degrees. It's a right angle. So if you have 90 plus 36, that's going to take you to 126. To find x, you're going to do 180 minus 126 to find the missing part, because remember a triangle has 180 degrees. You have to know that for tomorrow or you are out of luck. So x equals 54. Okay, now if you notice, x and y, those are vertical angles. They're opposite, and they share that common endpoint. So if x is 54, y is also 54. Okay, on number 9, your picture does not look like this. I think this angle right here is just x. I want you to change it to make it 3x plus 10. If you don't change it, you're going to get some crazy fraction, and we don't want that. So you're changing number 9 to 3x plus 10. So instead of x, it's 3x plus 10. Okay, a triangle has 180 degrees. Okay, so you're going to go around and add your like terms. So we have 3x plus 3x plus 3x. So 3 plus 3 is 6. Plus 2 more is 8, so I have 8x. Okay, 10 plus 5 plus 5, that's a positive 20. That has to equal 180 degrees. Why 180? Because the triangle is 180. Okay, subtract 20 on both sides first. So I have 8x equals 160. Then when you divide by 8 on both sides, you're going to get x equals 20. Okay, on number 10, this is the exterior angle sum. This question is on your test. To find the exterior angle, remember, you're going to take the two angles that are furthest away from it. Okay, so you're taking the two angles that are furthest away from it, so 70 and 64. You're first going to add those two up, and that's going to be your answer. So we have, oh my bad, 64 plus 70. So if you do 64 plus 70, you're going to get 130, oh my bad, not 2, 134. So x is 134. And you don't need the y part. I don't know why that's there. So if you want, you can just cross it out, whatever. Okay, number 11. If you look right here, you have these two curve marks. That's telling you that those angles are congruent. Okay, if angles are congruent, you know that the sides opposite them also have to be congruent. So you know these sides are congruent. If the sides are congruent, how do you set an equation up? Set your sides equal to each other. So I have 2x plus 6 equals 3x minus 6. Okay, move your smaller variable. So I'm going to subtract 2x on both sides. So I have 6 equals x minus 6. That's an x. Okay, to solve for x, you're going to add 6 to both sides. Oh man, this is getting really great. Okay, so we have x equals 12. And on number 12, you first want to look at your right angle. So this is telling you that that's 90 degrees right there. Okay, also if you look at these sides, those sides are equal. So if your sides are equal, then the angles opposite them also have to be equal. Okay, y'all, a triangle is 180 degrees. Okay, so if I do 180 and I'm going to subtract off this 90 angle right here, I'm going to subtract off 90 degrees. 180 minus 90 is 90. So that's telling me that I have 90 degrees to split up evenly between x and 9y. Why do I know I'm splitting it up evenly? Since these sides are the same, the angles opposite them have to be the same. So this angle plus this angle has to equal 90. Okay, so it's like you're just taking 90 and you're going to share it between these two angles. So you're going to do 90 divided by 2. 90 divided by 2 is 45. So that means x is 45. And if this angle down here is 45, you're going to do 9y equals 45. To solve for y, you're going to divide by 9 on both sides, and you're going to get x, or y equals 5. Okay, on number 13, it says decide if a triangle can be made. This is part of your free response on the test. You're going to be given 3 lengths, and it's going to ask you if you can make a triangle or not. Okay, remember to make a triangle, the sum of the two smaller, so I'm going to do 2 small, have to be greater than the other side. So first identify the 2 small sides. So I have 7 and 6. Add that up. That's 13. Is 13 greater than 12? Yes, it is. So a triangle can be made. So since a triangle can be made, you're figuring out, and we're not going to name the triangles by the angles. We're only going to name it by the sides. So since if you look at the sides, all three sides are different, that means your triangle is scalene. So scalene is all three sides different. Isosceles is two sides the same, and equilateral is all sides the same. Okay, I'm going across to B. Find your two small sides, 5 and 4. Add those together. 5 plus 4 is 9. Now, your last side is 9. 9 equals 9. It is not greater than 9, so you cannot make a triangle. Let's come down to C. So you're taking your two smaller sides, 9 and 14. Okay, 9 and 14 is 23. Is 23 greater than 25? No, it is not. So since it is not, you cannot make a triangle. Remember, the sum of the two smaller have to be greater than the other side. And on D, find your two small ones, 5 and 12. 5 plus 12 is 17. Is 17 greater than 13? Yes, it is. Okay, so you can make a triangle. What type of triangle can you make? Since all three sides are different, it can be scalene. 14, it says identify the longest side, shortest side, and then on 15 is telling us to 15 is to identify the largest angle and smallest angle. Okay, your longest side is across from your biggest angle, okay, and vice versa. So first you need to complete the triangle. A triangle has 180 degrees. If you add up 85 plus 50, okay, so if we do 85 plus 50, we're going to get 135. So to find the missing angle of A, we're going to do 180 minus 135, and you're going to get 45. So angle A is 45. Now, if you're trying to find the longest side is across or opposite from the biggest angle. So our biggest angle here is 85. So if you go straight across, the side is AC. So that is our biggest side. Okay, your shortest side is across from the shortest angle. So if you find your smallest angle, which is 45, 45 is across from which side? BC. Okay, y'all, these are two questions on the test. 100%. I'm telling you right now. 15. You're finding the largest angle. So luckily, we have our three sides. We have 6, 7, and 8. To find the largest angle, first identify the longest side. So 8 is our longest side right here. I'm going to underline it in purple. Or try to. So 8 is our longest side. To find the biggest angle, go to your longest side, which is 8, and go straight across to the angle. So the largest angle has to be C. To find the smallest side, to find the smallest angle, find the smallest side, which is 6, and find the angle that's across from it or opposite from it. That is angle B. Okay, 16, it says, if triangle PQR is congruent to triangle JKL, then which following must be true? So you don't have a picture, so I would draw one. So you have triangle PQR. Remember, you want to label it in the same order. Is congruent to triangle J, that's a J, KL. Okay, we're trying to determine, is PR the same as JK? No, it is not, so A is out. Let's go down to B. Is PQ the same as KL? No, it is not, so B is out. Let's go to C. So angle RPQ, so that's really talking about angle P. So is angle RPQ the same as angle KLJ? No, it is not. So C is out. That means D better be our answer, but let's just check. So RQP is congruent to LKJ. Yes, it is. So we're good. All right. In 17, it says that triangle MNO, it says the measure of M equals the measure of O. So M and O are the same. So it says which of these statements cannot be the name for the triangle? Okay? if you have two angles that are the same, that means that the sides opposite those angles have to be the same. So that means MN has to be congruent to NO. The angles are the same, the sides opposite them are the same. Okay, if you have two sides that are the same, if you look at choice C, scalene means no sides are the same. But if you have two angles are congruent, that means you have two sides are congruent. So there's no way it can be scalene, because scalene means that all sides are different. Okay, number 18, it says triangle JKL and DEF. JK is congruent to DE and KL is congruent to EF, which of the following statements, if true, would lead to the conclusion that the two triangles are congruent by side angle side. So you don't have a picture, I would draw one. Tomorrow on your test, you better be drawing a lot of triangles and labeling. So JKL, label your picture the same way, D, E, F, and in the same order. Okay, so it's giving you information. It's telling you that JK is congruent to DE, so label that. And it's also telling you that KL is congruent to EF. Oh, that's not a Z, that's two segments, whatever. Okay, so it's saying you're trying to prove that the triangles are congruent by side angle side. Okay, you have two sides. Remember, when you're doing side angle side, it has to go in order. So if you have this side, the next thing you have to have is an angle. Okay, it has to go in order. Remember, the angle has to be included between the two sides. So the only angle that's included between those two sides is K and E. So you have to know that K and E are equal in order for it to be side angle side. Nothing else will work. Okay, number 19, we're going to jump into proportions. It says Jared is buying a pizza for a class party. It says if each pizza costs $12, including tax, and feeds 4 students, about how much money will he need to feed 23 students? So write out what you are comparing first. So we are comparing students, and we are comparing the cost of it. Okay, if you write it out, you can't mess it up. Okay, it says if each pizza costs $12, including tax, and feeds 4 students. So I know that $12.75 is going to feed 4 students. Okay, so I need 2 equal fractions. So $12.75, that's talking about money, so that's going to go on the bottom. That amount of money is going to feed 4 students. So students goes on top. It says how much money will he need to feed 23 students? So 23 is talking about students. Students is on top. So 23 is going to go on top also. That means for the bottom, you have to have x. Okay? Cross multiply and divide. So we have 4x. That has to equal multiplying going the other way. So you have 12.75 times 23. And that's $293.25. Divide by 4 on both sides. When you divide that by 4, you're going to get, and you're going to estimate since we're going to have to round, x equals $73.31. Okay, on 20 it says a 6-foot ladder touches the side of a building and a 0.5 feet above the ground. At what height would the 15-foot ladder touch the building if it makes the same angle with the ground as a shorter ladder? So we're comparing two things. We're comparing the ladder height and the point above the ground. So I'm going to do above ground. Okay, so I know I need a proportion. I need 2 equal fractions. So I have a 6-foot ladder. Okay, so that's my numerator. It says it touches the side of the building 5 feet above their ground. So that's the distance above their ground. It says like what height would a 15-foot ladder, so that's giving me the height of the ladder, so that's going to go on top. Okay, what would the height of the 15-foot ladder touch the building if it makes the same angle with the ground as a shorter ladder? So I'm trying to find what height above the ground it would be, so that's my variable x. So we're going to cross multiply. 6 times x is 6x equals going the other way. 5 times 15 is 75. When you divide by 6 on both sides, you're going to get x equals 12.5. Okay, remember, if you label what you're comparing and make it in fraction form, there's no way that you can mess this up. So get what you're comparing in words and then set up your proportion. Alright, 21 says find the value of x. So I have my two parallel lines, so I know that it's going to cut my segments off proportionally, and that's good because it's going to be easy to set up proportions. Okay, so first I need to find, since it's cutting it off, I need to find this little length right here. I know the whole length is 20, and I know this part is 8. So to find this length right here, I'm going to do the whole part minus 8, and that's going to give me the little length, so that little length is 12, because 20 minus 8 is 12. So here is my proportion. I'm going to do part of the left triangle over the other part equals, I'm going to go on the right side, x over the bottom part, which is 6. So if you cross multiply, you're going to get 8x equals, and 12 times 6 is 72. Okay, divide by 8 on both sides, and you're going to get x equals 9. Okay, 22. Same thing. You're going to set up a proportion. So I'm going to do the left side of the triangle over the left base of the triangle, or what it sits on, equals, go the other way, the right side of the triangle over the right base of the triangle. Okay, I don't care however you set your fraction up, but just go in the same order that you do the first one. Okay, so I have cross multiply. 7 times 10 is 70. If you go the other way, you have 5x. Okay, so if you do 70 divided by 5, you're going to get x equals 14. 23, you have two parallel lines. Okay, that's going to cut your fractions off proportionally. I'm asking to find x. So I'm going to do the part of the left over the bottom part of the left has to equal part of the right over the bottom part of the right. So I'm going to have x divided by 18 equals 6 over 24. Okay, cross multiply. 24 times x is 24x. 18 times 6 is 108. Divide by 24 on both sides, and you get 4.5. Okay, on 24, I'm looking right here. I know that these angles are equal because they are vertical angles. So if I'm trying to find x, I have the far left side and the far, that's going to match up with the far right side. Okay, these are two triangles are kind of like a mirror image of each other. So 21 is really going to match up with 18. So take care of the left triangle first and then do the right triangle. Okay, so let's do 21 divided by x equals, take 21's corresponding side. 21's corresponding side is 18. So equals 18 divided by 24. Okay, cross multiply and divide. You're going to get 18x equals, and 21 times 4, or I'm sorry, 21 times 24 is 504. Okay, divide by 18 on both sides, and you're going to get x equals 63. Okay, 25. Those little play buttons, remember that means they're parallel lines. So if you have two parallel lines, these are your parallel lines, and this line right here is your transversal. That means you're going to have alternate interior angles that are equal. So those are equal, and then right here I also have vertical angles. Okay, so when I'm setting this proportion up, I'm trying to find x. So I'm going to do the small triangle over the big triangle. So I'm going to do x divided by 6 equals, okay, now you're trying to find the corresponding side with x. Okay, if you look at x, it's part of the segment with the 2 curve marks and no other curve marks. So you need to find that other segment on your bigger triangle. So I have 2 curve marks here and no other curve marks here. So x actually matches up with 20. So I have 20 over, and 6 is going to match up with 10. Okay, so cross multiply and divide. So you have, and I'm running out of room, you have 10x equals, and 12, or 6 times 20 is 120. So when you divide by 10 on both sides, you're going to get x equals 12. Okay, number 26, it says find QR. So we're looking for this right here. It says MN is 15, label your picture. NO is 18, and PQ is 12. Okay, so since these lines are parallel, I know by those arrows right there, that means your the parts of the segment are going to be cut proportionally. So that's nice, because pretty much you should be able to see your fraction. So it's really 18 divided by 15 equals 12 divided by this right here, which I'm going to name that x since we don't know what it is. So I have 18 divided by 15 equals 12 divided by x. Cross multiply and divide. 18 times x is 18x, and 15 times 12 is 180. When you divide by 18 on both sides, you're going to get x equals 10. Okay, if you come down to 27, it's a proportion. Just cross multiply and divide. 15 times x is 15x. That has to equal, multiplying going the other way, 6 times 10 is 60. When you divide by 15 on both sides, you're going to get x equals 4. Okay, 28 is the same thing, but since you have more than one term in your denominators, you're going to need to first put parentheses. Okay, once you put parentheses, then you can cross multiply. Okay, so we're going to cross multiply. Now, since you're multiplying a value into parentheses, you're just going to rewrite it first. So this is really 4 parentheses x plus 7. That has to equal going the other way. Again, I have parentheses. I have a number. Put the number in front of the parentheses. So 3 times 2x minus 5. Okay, because you're really distributing that 3 into each thing in the parentheses. Okay, draw your wall. You're going to distribute 4 times x is 4x. 4 times 7 is positive 28. That equals 3 times 2x is 6x. 3 times 5, negative 5 is negative 15. Okay, you're going to move your smaller variable, so I'm going to subtract 4x on both sides. So I have 28 equals 2x. Bring down your negative 15. Okay, I'm going to keep going. I'm going to add 15 to both sides. So when I do 28 plus 15, you're going to get 43 equals 2x. Divide by 2 on both sides. And you're going to get x equals 21.5. Okay, all because you got a decimal doesn't mean you did it wrong. Okay, 29, you're going to set up your triangles proportionally to each other. Okay, so pretty much your triangles match up. So you should be able to see 2 triangles here. It's really like 2 triangles, 1. You have this small one right here. Okay, and you have this big one right here. Okay, they're similar by angle. So our parts are going to be proportional. This is indirect measurement. So I'm going to do the base of the small over the height of the small. So I'm going to do 12 divided by 9 equals, follow the same order, but with the big triangle. Base of the big, which it tells me it's 28, over the height of the big triangle, which is x. There's your proportion. 12 times x is 12x equals 28 times 9 is 252. Okay, divide by 12 on both sides, and you're going to get x equals 21. Okay, on problem 20, on 30, it tells you that the polygons are similar. That's very important because you know the angles are congruent in your sides are proportional. Okay, that's very important. You have to know that the angles stay the same. So I'm going to go take care of all the angles first. Okay, these two polygons, they're similar, so your angles are going to be the same. And take corresponding angles. Corresponding angle means angles that are in the same position. So 87 is in the same position as C, so C is 87. B is in the same position as 85, so B is 85. And 60 is in the same position as A, so I know 60 is A. Okay, once you found those, now you got to find the side lengths. First, find a similarity ratio. So take two corresponding side lengths and just make a fraction out of it. So I have 12 divided by 8. So 12 divided by 8. Okay, I'm going to simplify that first so it's easier for me to use. When I simplify that, that's 3 over 2. So I'm going to use 3 over 2 to find my other similarity ratios. Okay, remember I started with the 12, so I'm starting with the big picture, and then I went to the small one. Okay, so to find x, okay, x and 10 are corresponding. So I'm going to set up my similarity ratio. So I have 3 over 2. Okay, I found that from right here, doing the big picture over small. So since 3 is big, which one out of the x and the 10 come from the big picture? The x does. The x comes from the big picture, so x is going to go on top, and 10 is going to go on bottom. Cross multiply and divide. You have 2x equals 30. When you divide by 2 on both sides, you get x equals 15. Okay, use that same similarity ratio to find y. So we're going to do 3 over 2. Okay, now if you look at y and 16 are corresponding. You just got to determine, does y go on top or bottom? So since y was in our bigger picture and 3 is the bigger number, y is going to go on top. And that means 16 is left to go on bottom. So if you cross multiply, you get, not 3y, my bad. You're going to get 2y equals 48. And when you divide by 2 on both sides, you're going to get y equals 24. Okay, you're going to have to do that one more time to find z. So I'm going to use my same similarity ratio, so 3 over 2 equals. Now if you find z and 9 are corresponding. So determine which one is from the bigger picture. 9 is from the bigger picture, so that goes on top. And then z goes on the bottom, cross multiply. So 3z equals 18. When you divide by 3 on both sides, you're going to get, z equals 6. Okay, 31, it's another indirect measurement problem. Okay, these set up very nicely because you have two separate triangles. So we're really looking for the question mark X. It says the sunlight hits the top of a pole and a building at the same angle. The pole is 10 feet tall and casts a 20-foot shadow. The building casts a 100-foot shadow. What is the height of the building? So we're going to do the shadow over the height. So I'm going to do shadow over height. So the shadow of the flag is 20 over the height is 10. That has to equal the shadow of the building, which is 100, over the height, which we're trying to find, which is x. Cross multiply. 20 times x is 20x equals 10 times 100 is 1,000. Okay, divide by 20 on both sides. And you're going to get x equals 50. You might be seeing this question again very soon. And 32, it says decide whether the triangles are similar. So similar means by a angle. Okay, on 32, I have one angle that's congruent that I know of. Look right here. These angles, you'll have to know those. Those are vertical angles. So since they're vertical angles, yes, they are similar. How? By angle. So to prove triangles are angle, all you need to do is, to prove triangles similar, all you need is to find two angles are congruent. On 33, you're first going to have to complete the triangle. A triangle has 180 degrees. So if you do 80 and 50. Okay, you're trying to find the missing angle B. That's going to be 50. Okay, and on the other triangle, you have 80 and 60 so far. You're trying to find the other missing angle, that is 40. Okay, now if you look, you have 80, that is the same, but no other angles are the same. So since no other angles are the same, and that's supposed to be a note, you cannot prove that those are similar. Okay, so this is the end of the review. Make sure you go over your notes. Make sure you go over any other review questions that you might have missed, or you need to replay part of a problem. If you have any questions, make sure you ask me before the test tomorrow, and good luck.